Welcome to the series of videos on C++ programming. In this video, we'll study the other form of structures known as union. So, the plan is simple. First, basic concept of union, then basic syntax followed by declaration and initialization, and a few working programs. Whenever we wish to represent a group of items as a single unit and saving space, in those conditions we use unions. Now the syntax is just like the syntax of a structure. Union is a keyword, so we can use it only in the way it has been designed for or defined for. Then some name which must be unique in the scope, pair of braces, these two, followed by semicolon, the statement terminator, and within this pair of braces you can have as many variables of different or same data type as you require. So here where one may be of same data type and this data type may be different. How to use union, the same name, and create a variable of this type. And how to access name of the variable so created, then dot operator, and the name of the variable or the member which we wish to access. So here it is, this one, and of course semicolon as a statement terminator. Union also support nesting just like structure. Union name just like this, then some data type, a variable of some data type. Then within the union we can have another union, name 1, it has to be unique again in this scope, the pair of braces, semicolon, and one or more variables of same or different data types. But if we want to nest one union inside the other, we need to create a variable of that type. So name 1 is a union, so create a variable of this type, union name 1, and suppose this var3. How to access? To access, create a variable of outermost union. So this is where. To access its member, var dot var1. So this will bring us to this one. Now if I want to access this, so first create a variable. We have already created a variable of type this name. So it is var. This dot var3 will bring us to here, to this location, suppose, for understanding, and dot, it means its member, will bring us to this variable, that is var2. So this is the way we can access the members of nested unions as well. Now let us see some working programs. So in this program, I have declared one union named student, and it has 3 members. One is a character array of characters of size 20, one height of type int, that is integer, and one CGPA which is of type float. Okay. Now the difference between union and structure is that in case of a structure, the size of this student, when a variable of it will be created, so the size of this s1, or you can say union student, will be 20 plus whatever is the size of height and whatever is the size of CGPA. So maybe 4 plus 4. So total amount of memory occupied by a structure of this type will be, you can say, 28. Okay, 20 plus 4, 24 plus 4, 28. But in case of union, it will be the size of the biggest data type which is a member of this union. So here it is name. So later we'll see that actually it happens. So here I have created a variable of this type s1, and I repeat in the previous video, to we cannot assign strings like this directly using the assignment operator. So this is the way we use this C string function, which is defined in C string in case of C++. So we have to hash include C string. Now then I have assigned 170 this value to this integer and this value to this float. Now when we try to take the printout or the values of all these, if we want to print the values of all these three members of S1, the result would be slightly different. So let me execute this. I can see here. So first value printed is some arbitrary character. In your case, it may be something different. Now here it has printed some arbitrary value, and here it has printed the correct value. Why? Because in case of union, it behaves like a single variable of what type, which has been most recently used. So now onwards, here the name, this S1 is behaving like a string. It is holding a character string. But immediately after that, we have assigned this value. So now S1 will behave as an integer. Then we assign a float to a member, so it will it will behave just like a floating point number. That is why it has printed correct value for floating point number, but rest two values are arbitrary. Okay. Now what we can do is we can assign a new value to some, suppose, height. Again we have assigned. Now you can see this name is some value here which is not correct. Then height is 170, you can see here. But again, now for floating point number, it is printing some arbitrary value here. Okay. So because as soon as it has come here, this statement 170, it is assigned, so it will behave as an integer. Now here also, if we do this, now it will behave as if it is a character string. So now I can again see here, it is printing correct value ABCD, then some arbitrary value, and then another arbitrary value here. Okay. Now if you know the internals, we can make out what would be the values printed corresponding to these, but we cannot trust those values except the last value assigned, that will be given correctly. Now there is an operator size of, using which we can find out how many bytes this union would, or variable of that type would occupy, size of. Now you can see here it has printed 20, because character array is the biggest data type which is a member of this union student. Okay. Now in this case, nesting is also possible like structure only. You can have as many unions one inside one another as you require. In the next video, we will study local and global variables. That is all in this video. Thanks for watching.